Welcome back everyone to the channel. I've seen a lot of engagements in my previous AI agent build video where I showed you a step-by-step guide on how to build our personal AI assistant Altiera. Thank you to all those who took their time trying out the AI agent build for themselves. And if you're new to this channel, please check out my other videos linked above and hope you can get relevant bits about the limitless possibilities that AI is able to do right now. Before I proceed walking you through how I built this new AI assistant in N8N, let me show you the logic behind this entire system. Here, you can see the process map of this whole AI agent build using different nodes and integrations available within N8N. Moreover, this entire system is powered by 6 different workflows, 1 for the main AI agent workflow, 2 automation workflows, 3 tool workflows, carefully crafted and integrated into a single symphony of AI automation system with one single purpose: to become your very own personal AI accountant. Enough of the talk, let me show you an actual capability of this AI personal accountant whom we named Ada. Awesome, right? Look at how Ada handled every request I made, and the possibilities are limitless for this personal AI accountant. Today, I'm going to take you on another exciting journey of building yet another powerful AI assistant that can boost your daily productivity. Meet Ada, your personal AI accountant built using N8N. An automation platform that allows you to create sophisticated workflows easily. This AI agent, named Ada, is designed to help users manage their finances by interpreting user commands, recording transactions, generating invoices, and summarizing financial reports entirely from a Telegram chat interface. We'll be walking through the entire process, showing you step by step how I built Ada using custom workflows and tools like add transaction, record invoice, summarize finances, and more. So, if you're interested in automation and AI, this video is for you. Let's dive right in. This is where the magic happens. The AI agent we're creating is called Ada, and she's capable of understanding user commands through Telegram and performing various financial tasks. Ada can add transactions, record invoices, and even summarize finances based on user input. Let me show you how I built this. First, we need our Telegram trigger node. This is our gateway to interact with Ada. As per usual, we need to create a bot from our Telegram account to set up our credentials here in N8N. Now this is our main AI agent workflow. As you can see, we have 2 different paths for the workflow. We have the Google Drive file upload actions path right here. This file upload action path is important for this build. Since Ada's purpose is to be our personal accountant, we want her capable of recording documents like bank transaction records and invoices for us as part of monitoring our financial activities. We built Ada with two main capabilities in mind. The first one is when the user have a specific document of a bank transaction or an invoice document uploaded within the Telegram chat interface, Ada retrieves the uploaded file, runs an OCR, optical character recognition tool, to extract the text, and then records the extracted information in either the transactions or invoices database that we created from a Google Sheets file. The other main capabilities we need from Ada is to execute commands based on user intent with the tool calling function AI agent workflow. This workflow here will be able to use different tools in order to execute whatever actions requested by the user. We will go through each of these tools later on in this video. As an overview of how this workflow functions in the background, let's go over each of the steps here. First, when our Telegram trigger receives message input from the user, the flow will run depending on the data it receives. When the user uploads a document or any valid file of a bank transaction or an invoice, even without context about what the document is about, as long as the file name is clear enough to distinguish whether it is a bank transaction or an invoice, the flow will course through the Google Drive file upload workflow. If the input is a message containing query or a conversational chat requesting Ada to do something, this workflow will do nothing because of this error handler here, which will execute a no operation, do nothing action. We can set this up by going to this Google Drive node, and in the settings under on error field, we set this into continue using error output option. This will create two different paths for the workflow, which gives us success and error paths. To make sure that we capture the document uploaded by the user from our Telegram chat, we need to set up a Google Drive file upload node here. Back in our Google Drive, we need to create a folder. Here we named it Personal Accountant Main. This is where we upload the document captured from our Telegram conversation. We have two separate folders here, one for the bank statements and the other for invoices. In our Google Drive upload a file node, we will stage the upload process here in the main folder before moving the files to the correct folder paths that we created. If a document is actually uploaded, we created another node, which is a basic LLM chain node. This basic LLM node will categorize the input based on a parameter we set. In this node, we will be required to attach an AI model. In this case, we employed the OpenAI model, and a structured output parser to make sure we get a consistent output from this LLM node, which will then be used by our succeeding nodes. Within this basic LLM node, we set the prompt to define below and use the Telegram message input. Then we gave it a system prompt, which will instruct our AI model what it will do. We gave it a prompt here. Your role is to identify the intent of the user based on two categories. Upload invoice. If the user explicitly implied to upload an invoice document in the current chat message or interaction, or if the document file name contains invoice. Upload bank statement. If the user explicitly implied to upload a bank statement document in the current chat message or interaction, or if the document file name contains bank statement. Then we also add a user prompt, wherein we identify the user chat message by dragging and dropping the output from our Telegram chat, which is the user message, the file name of the document uploaded, and the file upload caption whenever it is available. These items are coming from the metadata from our Telegram chat trigger, coming from our conversations with Ada. Next, we set up our output parser. We will implement a standard input schema using a JSON format. We create this using the example format provided by N8N, or you can also ask ChatGPT to create a customized JSON schema for you. This input schema will make sure that our LLM node will produce two output string objects, invoice and bank statement. Up next is an if node depending on the output provided by our LLM node. If the resulting categorized output is an invoice, we will set this into true. This will course the workflow into the true path, where we will then set up a Google Drive node that will move the file uploaded from our previously set up Google Drive folder, where we used to upload the document captured from our Telegram chat conversation. After we move the file to the correct folder path using the Google Drive Move File Action node here, we will create an Edit Fields node to create a response output, which we will send back to our Telegram chat message to make sure we alerted the user that the file is successfully uploaded to the correct folder path. The same process will be created for the other path in our if node, which will move the file uploaded by the user to the other folder path in our Google Drive folder, the bank statement folder path. These files uploaded by the user needs to be recorded into our main Google Sheets database. In our Google Drive folder, we created a Google Sheets file named Spending Tracker. This file will store all the bank transaction records and invoices generated from the uploaded document from the user, or if the user explicitly asked Ada to record a single transaction, which will be executed using the tool's capability we will give to Ada. If the user uploads a bank statement, it needs to be encoded into our transactions database. If the user uploads an invoice document, it must be recorded in the invoices database. For us to be able to record the contents of the documents uploaded by the user, we will create another automation workflow that will handle this action for us. Here we created two different automation workflows. One is for analyzing the invoices uploaded to our Google Drive folder, and the other one is for recording bank statements. Let's take a look at each of these automation workflows we created. First, let's dive into this invoice analyzer workflow. Here, you can see how this automation runs under the hood. We have here our trigger node, a Google Drive trigger node that will run whenever a new file or document is created within the invoices folder we created inside our main Google Drive folder. For our personal AI accountant, Ada, this node will trigger whenever a new document is created or uploaded in the folder. Remember how our previous workflow moved the file uploaded by the user from our Telegram chat to the correct folder paths? That is when this workflow will be activated in the background. After the trigger, we will create a new Google Drive action node that will download the file into our N8 and automation to access the contents of that specific file. We will then extract the contents of the uploaded file so we can process the data using an extract from PDF file node. Once extracted, we will set up an edit fields node to output the extracted PDF data into a usable string output data. Then we will use an advanced AI node called information extractor node. This node requires an AI model. We use the OpenAI chat model. Inside the information extractor node, we will define an input schema to get the correct data we want to be extracted from our PDF file. This schema will specify the data we will gather, such as invoice date, invoice number, billed to, and total amount values. You can create this schema using ChatGPT as well, depending on your data structure. Once we get the extracted data based from our required schema, we will then add another edit field node. This will transform the output from the previous node into an object we will name response. This will then be used by our next node. We create a Google Sheet append row in Sheet Action node. This node will encode the extracted data from the PDF file into the correct columns from our transactions database. This workflow will ensure that whenever a new invoice is uploaded to our Google Drive, it will automatically be captured by our automation and record new invoice data into the correct database. You can create the same automation to whatever application you may have for your own projects. The same logic is made for our next automation workflow, the bank statement encoder automation workflow. Here we have the same trigger node. When a new file is created or uploaded into the bank statement folder, we will download the file and extract the data from the PDF document. Using the edit field node, we will output the extracted data into a single string object named as output. Instead of an information extractor AI node, we will use the OpenAI message a model node to parse the extracted data. This is how our bank statement document looks like in actual. As you can see here, our goal is to extract each of these transactions data and encode them into our transactions database. In our AI message, a model node, we use the GPT-4.0 model to have a more accurate result. We will then give it a prompt. You are a text parsing assistant for bank statement of account document. Your task is to parse the text from a given output containing the bank statement data to separate each bank transactions with corresponding amounts. Output your response such that each transactions can be recorded separately by another node. See here how the output would look like from the extracted PDF data of our bank statement. It would take trial and error if you want this to work on your own document format before you get your desired output data. It is advisable that you use a more powerful AI model capable of accurately parsing data from a structured data source. Also, make sure you have a uniform document format for your bank statements. Otherwise, you might encounter inconsistency in the output along the way. Once we get our parsed output data from our AI node, we will use an edit fields node to transform and map the parsed data into a single array we will call transactions. In order to flesh out each of the transactions from our array of extracted data, we will use the split out node. You can see this node under the data transformation nodes within N8N. This will split our transactions data into multiple items needed to encode into our next node, the Google Sheet Append Row Action node. In the Google Sheets Append Row node, we will then map out the output data from our split node. Here we will drag and drop to the correct column fields each of the output values. We have the date, transactions, credit, debit, and balance. Let's move on to our AI agent main workflow. This is where the magic happens. The AI agent we're creating is called Ada, and she's capable of understanding user commands through Telegram and performing various financial tasks. Ada can add transactions, record invoices, and even summarize finances based on user input. Let me show you how I built this. After the Telegram trigger node, whenever the user did not submit any file or document, the flow will course through our main AI agent workflow. Here we created an edit fields node to capture the message input from the Telegram chat. This will summarize the context of the chat conversation that will feed into Ada for her to understand what specific action to execute based on the available tools she has at her disposal. We set the field as chat context. We use the chat input from our Telegram trigger node and file name and caption of the document uploaded by the user so that Ada is able to understand whenever the user uploads a document, which signals her to not execute any of the tools that are unrelated to this specific action. Now onto our main agent node. We use the AI agent tool node for this type of build. We gave it an AI model where we use OpenAI GPT-4.0 model to power Ada in the background. We also gave her a memory to be able to retain previous chat interaction. You can choose different memory tools. We have a free version, which is the window buffer memory for easier implementation. In my case, I used a Postgres chat memory, which I have set up in a self-hosted manner. If you are interested for me to go through these types of process in my future videos where I can show you how to set up different solutions that you can implement for your AI agent builds, please tell me in the comments below. Here's Ada's prompt. As you can see, we've given her a personality. Ada is helpful, professional, and empathetic. Her job is to act as an intuitive AI accountant, guiding users through their financial tasks with ease. Now let's explore how each tool is integrated into the workflow. For those of you who wants to follow along this walkthrough build, I'm giving you the blueprint for Ada in the link from the description below. As always, I'm giving away these resources for free. All I'm asking is for you to show some support by clicking the like button if you really like this content I made, or share this video to someone you know would benefit from this type of content. If you also are interested to see more of these AI agent builds and AI related videos in the future, you may click the subscribe button below so you don't miss any of my future videos. Enjoy, guys. Enough of the plugging. Let's get back to our build process. Let's talk about the first tool we gave to Ada. First up, the Add Transaction tool. This workflow is responsible for capturing financial transactions like purchases, payments, or any type of spending. Ada will ask the user for all the necessary details, transaction date, description, category, and amount, before recording it in a Google Sheets database. In the tool node, we need to define the input schema. This will make sure Ada is providing the correct output that will feed to the tool node in order to accurately receive the right data needed to execute the Add Transactions action. We will define all the needed parameters such as transactions date, category, credit amount, and debit amount. Follow the format provided by N8N to set this up. Let's head on to the Update Transaction tool workflow we created. Here we have the Execute Workflow trigger, which captures the data from our main AI agent workflow, where we will receive the exact JSON schema we set up. Once triggered, the data will flow into an open AI message, a model node. Here we gave it a system prompt to parse the data from the trigger node and output the parameters separately. We also set the user input into the stringified data from the trigger node. We toggle the output content as JSON to receive the output for our next node into a nice JSON format. Then we will append the output data from our AI node into the Google Sheets append row node. Here we will map out the data parsed by our AI node into the correct column field from our Google Sheets transactions database. We can drag and drop the values we get for the date column, transactions, category, credit amount, and debit amount. Let's also add an option to let Google Sheet format our data to ensure we are encoding the correct format for the dates and the amount values. Lastly, we set an edit field node to output a response needed by our main AI agent node, so that Ada will be able to know if the action to record a new transaction to our database has been executed successfully. The same process is made for the record invoice tool workflow. Again, we set up an input schema from our main AI agent call N8N workflow tool node. We need to output the invoice date, invoice number, total amount, and bill to details. To make things faster, you may duplicate the update transaction tool workflow and implement a few changes in each nodes. The same OpenAI message. A model node will be used to parse the input data from our main AI agent workflow coming from our trigger node. We will parse incoming data and output a stringified data object, which we will then map out to our Google Sheets append row node. Lastly, an edit fields node will provide the output data to our main AI agent workflow to signal Ada that the invoice has been successfully recorded to the database. Now for the last tool we provided Ada with, the Summarize Finances tool. This tool workflow will be called when Ada will be asked by the user to generate a report or summary of financial information from our Google Sheets database of transaction records. This tool will query our Google Sheets database of transaction records based on the filter parameters requested by the user. For example, if the user asked Ada to summarize all the non-essential expenses they made for a specific month or period, the report will be generated by filtering the month requested and the non-essential expenses category from our transactions database. This will return a simple report crafted by the AI model in the form of a response via Telegram chat to the user. Let's see how we built the tool workflow. In the main AI agent tool node, we defined an input schema where we identified the filter parameters needed to query our transactions database. Here, we specify all the data we need from the user, such as transaction date, transaction description, category, credit amount, and debit amount. These are all the column values present from our database, which is essential to conduct a query and generate a simple report or overview of our financial activities. Now here's how we built the Summarize Finances tool itself. First, we have the trigger node, which captures the data from the main AI agent workflow. From the output of this trigger, we then have the Open AI message a model node to parse the data and output each of the parameters separately and turn it into a stringified output data. We then create the next node, which is an edit field node. Here, we need to set the fields to output two different information we got from our previous nodes. One is the date, which will result in a string format date value, and the other is the category, which would have the values such as income, essential expenses, and non-essential expenses. The next node is a code node. Here we need a JavaScript code that will transform the stringified date value into a month name format. The purpose of this transformation is for us to be able to filter the database where we created a column with the month name values on it based upon each of the transaction dates we recorded. This node will ensure that whatever date value we get from our previous nodes, we will always return a month name value for the succeeding nodes to use. If you don't know how to create this JavaScript code yourself, do not worry since I generated this code with the help of ChatGPT. Once we have our data correctly formatted, we then create the next node, which is a Google Sheets action node that will allow us to query the transactions database by filtering the record based on the specified month name value and the category value from our previous nodes. This will return only the transactions that falls within the month period specified and the category tagging of certain transaction, whether it's non-essential expenses, essential, and so on. This Google Sheets Get Rows action node will then return us all the transactions based on the filters that the user specified for the report or summary intended to be reported by our AI accountant Ada. Then we create an aggregate node which will consolidate into an aggregated data output, in this case into a single list of values, all the data queried from our transactions database in the previous Google Sheets node. In the next node, we will create an edit field node for us to convert the aggregated data into a single string output or text output. We do this so that our next node, which is another AI node, will be able to interpret the incoming data in the form of text or string value. AI message, a model node in N8N, will usually throw an error if the input data is not a string or text value. This AI node will have the following prompt in it. Your role is to analyze financial transactions using the provided data. Give short but informative summary about the data you are given with to be reported to the user. Important, use the calculator tool to compute the correct amount. With this prompt, we also need to add a tool node, which is a calculator tool for this AI node to calculate values correctly in its responses. The last step for this tool workflow is to add the edit fields node, which will be used to map out the response from our AI model node. This response value will contain the response text from our AI message a model node and use it to deliver the financial summary or report generated for the users. Now for the last tool, what's an accountant without a calculator as a weapon, right? We add the calculator tool so that whatever comes out of the Summarize Finances tool workflow, Ada will be able to interpret those data and manage to calculate accurately to respond to the user with the correct information. The last two nodes of our main AI agent workflow is the Telegram response nodes with an error handler to make sure our workflow won't break if there are inaccuracies from the output of our preceding workflow nodes. So that's the full breakdown of how we built an AI accountant using N8N. Ada is capable of handling multiple financial tasks from a single chat interface, and all of this is powered by a few simple workflows and tool integrations. Whether it's adding a transaction, recording invoices, or generating financial summaries, Ada automates everything for the user, making finance management much easier and more efficient. For those of you who got this far in this video, thank you from the bottom of my heart for taking your precious time watching this step-by-step walkthrough of how I built an AI accountant using N8N. If you found this video helpful, don't forget to like, share, and subscribe for more awesome content on automation and AI. See you in the next video.